Okay. So we're just recapping yesterday. The first two are super simple. We're looking for slope. What is slope always touching? The x. Because we know y equals mx plus b or y equals b plus mx. Does it matter the order? No. Okay, but slope is always touching our x. So when we look here, what's in front of our x? Negative 1/4. Don't forget the negative. So what's my slope on number 2? Negative 3. Pretty simple. Well, like those are easy, yes? Okay, next is graphs. I feel like this is where we struggle the most, just because we question if we want to use rise over run or if we want to use the formula. So I'm going to do one in both ways, yes? Okay, so on the first one, we will do rise over run. And before I even get started, y'all, what kind of slope is this? Negative. So before I forget, I'm going to put a negative. And then we have to find 2 pretty points when we're doing rise over run. So I can see that the origin is a pretty point, and here's another pretty point. Here's a pretty point. There's a bunch, okay? Remember, rise over run. Rise can be up or down, and this is negative, so we're going to go down. So we go down 1, 2, 3, 4, 5. So this went down 5. And everything's counting by 1, so we're good. And then right 1. So my slope is negative 5 over 1. Now, what's negative 5 divided by 1? What kind of 5? Yeah, so this is the same thing as saying negative 5. Okay, if we truly simplify it, this would be our answer. So we always write slope as a fraction if we're graphing. That's why it goes from this to this, okay? Now, if we don't use rise over run, it still works. We're going to identify 2 points. So I can see this point. I'm just going to put some dots on some pretty points first. I feel like sometimes we struggle finding the ordered pair from an axis just because we forget which spot 0 goes in. So I'm not going to pick an intercept. Okay, I'm going to pick these 2. So when I look at this point, remember we always go to the x-axis first. So the x of that point is 4, right? Everybody agree? And then the y of that point is what? What kind of 4? Negative 4. So that point is 4, negative 4. Okay, so when we find one more point, what's the x of this point? 8. And what's the y of this point? Negative 3. So if we follow our y2 minus y1 over x2 minus x1, I'm going to label this one x1, y1, x2, y2. So my y2 is negative 3 minus my y1 is negative 4. We have to plug in both of those negatives. And a lot of times when we replace x and y, we can use parentheses. If you don't use parentheses, you'll still get the same answer. Just know you have to type this negative and this negative, or the minus and the negative. Okay, and then x2 is 8 minus x1 is 4. And then from there, it's just a calculator problem. Remember to hit divide first. We have negative 3 minus negative 4. Okay, and then 8 minus 4. Okay, and do I want my slope to be a fraction or a decimal? Fraction. Okay, so my slope is 1/4. Now, was rise over run faster? Yeah. The big thing with rise over run is you have to make sure your graph is counting by 1s or whatever it's counting by, yes? So if it's not counting by 1s and you're struggling to figure out what it's counting by, please use this, okay? If it's counting by 1s and you're good, do rise over run. Cool? Questions, comments, concerns? Okay, let's look at tables. Okay, there's 2 ways to do tables. Both of them are pretty much the same thing. It's the y2 minus y1 over x2 minus x1. It's just how do you want to set it up. Okay, so you can do, remember, bottom minus top. Isn't that technically y2 minus y1? Yeah, so when we do that in our calculator, we have -1 minus 3.5, and that gives me -4.5. And then again, bottom minus top. So -2 minus -5, and we get 3. And then remember, it's change in y over change in x. So -4.5 divided by 3. Now, do we leave fractions with a decimal in them? No, that's not normal. So we're going to type it in here. Not 1. 4.5 divide 3, and it's going to simplify it for us. So my slope here is -3 over 2. Does that make sense? We're okay with that? So the same concept here is if we do x2, y2, x1, y1, it does the exact same thing. So our formula is y2 minus y1. So what's my y2? Minus what's my y1? Okay, what's my x2? Minus what's my x1? So now we'll just type in your calculator. So it just depends. Do you want to type it 3 times or you want to type it 1 time? That's the only difference in the two methods, okay? So here, remember, click divide first. 7 minus 1 over 2 minus 0.5, and we get 4. Okay, what do we notice on number 7? All the x's are the same. If we follow the same thing like we did on number 6, it still works if you forget what that means. Okay, so I'm going to show you that it still works, and then we'll talk about it. So, again, x1, y1, x2, y2, and we plug it in, so -4 minus 2, y2 minus y1, over x2, which is -2, minus x1, which is -2 as well. Everybody okay with how I plug that in? So when I type this in, type divide first, -4 minus 2 over -2 minus -2. What does it tell me? Undefined. Do y'all remember Slope Dude yesterday when all the x's were the same? That was his nose. It's a vertical line, and it's an x equals equation. Okay? And we'll get my posters up, I promise. Okay, and then the last two, or 3. I'm going to just do these 2, just because it's the same thing over and over again, right? Okay, this is just a fancy way of writing an ordered pair. This is function notation. We talked about that last week, right? Okay, what's inside the parentheses, x or y? Yeah, this is your x, this is your y, so it's just an ordered pair, -9, -10. So what's this point? 6, 0. Now, do we have an x1, y1, x2, y2? Yeah. So x1, y1, x2, y2. And we're going to plug it in to here. So what's my y2? Y2, not x2, 0. Minus y1, -10, over x2, minus x1, -9. So we have to put in those double zeros. 0 minus -10 over 6 minus -9. Now, we don't want that ugly fraction, decimal, so we turn it into a fraction. So m is 2/3. Okay, last one, what do you notice? Anybody notice anything? It's okay if you don't, because it's still going to work. Everything, it's already in parentheses, right? We don't have to change it like this one. That's a good thing to notice. What else do you notice? The y's are the same. So is this going to be a special case? Anytime the x's match or the y's match, it's going to be a special case, okay? When the x's match, it's undefined. We just talked about that on number 7. So let's see what happens here. So y2 is -7 minus y1 is also -7 over x2, which is 4, minus x1, which is -2. And when I type that in, what does it give me? 0. So remember, when the y's match, your slope is 0.